Welcome to Spring Lib.
Okay. Kind of interesting question. We're asked how the voltage of the Earth would change if some electrons were removed from a 3.5 millimeter diameter raindrop. So to deal with this, we total charge of the Earth, and then use the familiar expression for the electric potential of a sphere, 1 over 4 pi epsilon naught, q over radius. In this case, we're going to be using the total charge of the Earth over the radius of the Earth. We're going to see how that little change in charge results in a little change in voltage. Now, we'll need a little bit of space for this. So if we assume that all the charge on the Earth is on its surface and we ignore what's going on inside, first thing we would do is we would figure out the charge of each individual electron, which is 1.6 times 10 to the negative 19 coulombs per electron. We would then multiply by 10 electrons for one hydrogen molecule. We would multiply that by the number of molecules, 6.02 times 10 to the negative 10 to the 23 moles per 0.018 kilograms. We would then go from kilogram. We would note that 1,000 kilograms per meters cubed is about the density of water. And we would multiply by the volume of our droplet, 4/3 pi 0.00175 meters, the radius, cubed. After doing this huge conversion, we should end up with 1,203 coulomb. So plugging that in to our expression, 1 over 4 pi epsilon naught, charge times over the radius of the Earth, which is something large. We would have about 8.99 times 10 to the 9 Newton meters squared per coulomb squared, multiplied by our charge, 1,203 coulomb, over the radius of the Earth, which is about 6.38 10 to the 6 meters, which comes out to be 1.7 times 10 to the 6 volts. So the difference would be literally 1.7 million volts, megavolts. So it's pretty significant, pretty large. All right, so make sure you understand these conversion factors, how we got all the way to the total charge lost due to the raindrop, and that's it.